As you grow in your career as a civil or structural engineer, your responsibilities goes beyond just designing structures. You often find yourself advising clients on the financial aspect of bringing those designs to life. This is where an accurate cost estimation comes in, and this all starts with a precise material takeoff and a solid bar bending schedule. Welcome to DBK Consult. In today's video, we'll dive into the core principles you need to prepare an accurate material takeoff. This video is not just for engineers. If you're an architect, quantity surveyor, or a project engineer, you will find this video incredibly useful. You can also download the template used in this project by following the link in the description. And if you find this video helpful at any point, do not forget to like, subscribe, and share to other audience. It really helps my channel to grow. So let's dive into what we have for the day. Hello, welcome back to DBK Consults, and today we shall be going into materials and cost estimation. So this is very useful when you are trying to advise your client, or you're trying to get the total cost of all the different materials or all the different reinforcements required in order to construct your designed structural members. So we shall be doing this for this equipment foundation. We have an equipment foundation over here, and we shall be making use of this material takeoff table. So in the course of this lecture, you also get to understand the basics of your bar bending schedule, because that is what will enable you to have a proper material takeoff. And as earlier said, we shall be making use of this equipment foundation, which we have over here, comprising of a beam and a slab, right? So what I would like to remind us is, when we have a complete structure, let's say we have a 5-story residential structure, right? You will agree with me that it comprises of your different beams, it comprises of your slab, comprises of your foundations, right? So today we shall be looking at how you can estimate for just this set of beams, and the idea you get from these beams is what you can use for the estimation of other structural members on your complete structure. So we'll be looking at this equipment foundation, as earlier said, comprising of this 4 numbers of beams, which are categorized into beam 1 and beam 2, mostly because they have the same properties. They have the same these 2 beams over here, they have the same length, they have the same width, they have the same depth, they have the same numbers of reinforcements, right? So they are categorized as the same type of beam, okay, both for the beam 1 and the beam 2. And these are the properties of the beam 1, while these are the properties of the beam 2. So the ideas and the principles required to estimate the cost of these 2 beams, or the materials required for the construction of these 2 beams, is what you can use for the estimation of every other structural members. And with time, we get to see how we can also make separate videos to deal with your slabs, your pad foundations, your columns, as the case may be, right? So we shall be doing this in very easy steps, okay? Looking at this material takeoff table, we shall be doing this in very easy steps. The first step is we have to identify the various reinforcements that is in this equipment foundation beams, right? We'll get to understand the different reinforcements in these beams, and after identifying these different reinforcements, we get to look at their properties. And in the properties, we are referring to their length, we are referring to their diameters, their weights, and the total numbers in each of these respective beams. So when we have these properties, we can impute them in this material takeoff, and automatically we can calculate in tonnage the total quantities of the different reinforcements that is required for the respective beams. So quickly, let's move into the first step, which is identifying the different reinforcements in our structural members, right? So we'll be starting with the beam 1, and looking at the properties of our beam 1, we have the width to be 250 millimeter, and it has a depth of 1.2 meters. And as earlier stated, we have two numbers of this beam on this very model, right? So this is the elevation drawing of our beam, and this is the section drawing of our beam. As you can see here, we have the depth as 1.2 meter, we have the width as 250 millimeter, and we have the thickness of our slab as 300 millimeter. But we'll not be dealing with our slab in the course of this very tutorial. There will be separate classes to deal with our slabs. So the best way to identify your various reinforcements in your structural members is working with your bar marks, right? And on this beam 1 here, right, we have our bar mark 01, or we can quickly identify this from the section drawing. So we have our bar mark 01, we have bar mark 02, we also have bar mark 03 and 04, right? So let's start off with the bar mark 01. Okay, so for the bar mark 01, we have this to be, or permit me to divide this screen. Let's divide this, or let's take this to the left hand side, and let's keep the section drawing at the right hand side. Okay, so for our bar mark 01, we have it to be 4y16, 01 and T1, right? Which means we have four numbers of these reinforcements, okay? And the diameter of this reinforcement is 16 millimeter, or we can say the type of the bar is Y16, okay? The diameter is 16 millimeter, and our bar mark is 01, and this is at T1, which is at the top bar level 1, okay? And we can clearly see this from this section drawing. So we have it as 01, and we have it as 1, 2, 3 and 4, and it is at the top level of this beam, right? Considering the fact that we can have more than one layer of reinforcement in your beam. So in that case, the annotation will be T2. Okay, so we have 4y16 with bar mark 01 at the layer 1. So that's the first reinforcement in this beam which we have just identified. Okay, so we move on to bar mark 02, and that is our bottom bar. So we have this to be three numbers of diameter 20 reinforcements of y20 having a bar mark of 02, and it is at the bottom layer 1 of our reinforcements. Okay, also considering the fact that we can have more layers at still the bottom level. Okay, so this is the second reinforcement in this beam. Now the third reinforcement we have in this beam is our side bars, and as you can see over here, this is our side bars, which runs from this point. It runs from this point, okay, down to this point. Okay, and if we come over here, we can see the side bars, or most times it is known as your web reinforcement. Either you call it your side bars or you call it as your web reinforcement. All right, so we have it to be two times three numbers of y16 with a bar mark 03. Okay, so as you can see it over here, we have it to be three numbers, which is 1, 2 and 3, right? And we have it to be two of these three numbers because we have it both on the left hand side and also on the right hand side. So it runs from here to this point, which is from this point up to this point. And the diameter of this reinforcement, as clearly stated here, is 16 millimeter. So the last reinforcement in this beam, which is our bar mark 04, is our links, right? This is our links, and let's have a look at what this reinforcement looks like. So if you put this up, this is what our bar mark 01 looks like. As you can see from this picture, we have it to be four numbers, right? This is our bar mark 01. This is an example of what it looks like. This is our bar mark 02, right, having a different diameter of reinforcement, but in that case we have it to be three numbers of 20 millimeter. Okay, this is the third reinforcement which we have just looked at. where we have three numbers of 16 millimeter running from this point to this point. But in the course of this very picture here, we have it to be just one number, right? And the last reinforcement which we are just about to look at is our links, right? Our links or our shear reinforcement. So we have it to be this very reinforcement over here, which is this, and it runs across this beam. It runs all across this beam, right? So we have this to be our links having a bar mark of 0.4, okay, having a bar mark of 0.4, and it runs from this point of the beam to this point of the beam, and it runs within a space of 250 millimeter, which is to say we have this reinforcement space at 250 millimeter. So this is more like the first and the most important part of making your material take off, which is identifying the various reinforcements in your respective structural members. It can be a slab, it can be a pad foundation, it can be your columns, right? Identifying the various reinforcements in your beam is very key, because this is what will help you in the other processes that is required to estimate your materials. So now that we've identified the various reinforcements in our beam 1, the next step will be identifying the properties of these various reinforcements, right? So permit me to make a copy of this, and I will copy this from here down to this point, and we'll start looking at the different properties of these different reinforcements. So in order to get the different properties which we will impute in this table to help us calculate the total tonnage required, the next thing you need to look at, or the next thing you need to identify, is the various shape code of this reinforcement, right? These different reinforcement that you've identified. And this shape code is not something you have to develop yourself. It's something that is universal, so long as you are designing or you are detailing with a code of practice, okay? So it is not something that you have to develop yourself. It is given by your code of practice. And what contributes to the different shape code is the different ways in which your reinforcements are bent, right? So let me take this to a single screen, and I'll take this to single, right? So we'll be starting off with our bar mark 01, right? Because a lot of other properties are tied to this shape code. So our bar mark 01, if we pull out our shape code chart, let's pull this out. If you pull out this shape code chart as given by your BS 866 2020, since I'm detailing or I'm preparing this material takeoff with respect to the British code, right? You will see that we have the different shape code respective to how these reinforcements are bent. So if you have a straight reinforcement, we have this to be 0.1. If we have this type of reinforcement, this can be a column, right? A column with a development length. So we have this, we have the shape code as 11, we have this as 12, we have this as 13, right? So it all depends on the different way those reinforcements in your beams are bent, or the reinforcements in your slabs are bent, right? So for our bar mark 01, let me put this here, and let me put this here. So we'll create a copy of this. I'll select this and I will copy this downward, right? Let me just take this reinforcement to this point. So from this bar mark 01 over here, you will see that we have one length here, right? We have one part of the reinforcement here, and we have it bent towards the right, okay? So we have it continuous up to this point, and we have the same bent towards the left. Now do not forget that depending on the requirement of your beams, this can have a different length, right? And this can also have what? A different length, okay? It all depends on the requirements of the beam. So if we look at our shape code chart and we try to look for this type of reinforcement, you will see that we have that as shape code number 21, right? Which we have this part of the reinforcement and we have it bent to the right hand side, we also have it bent to the left hand side. So they can have the same length. This can be 250, this can be 250, and this can be 250, this can be 300 millimeter, right? So the shape code of our bar mark 01, we have it to be 21. All right, so we'll come back to this point and we'll identify this shape code. Let's take this to be shape code 21. Okay, so we'll create a copy of this for the second reinforcement, which is our bar mark 02. Let's edit this and let's take this to bar mark 02, right? So our bar mark 02, which is the bottom reinforcement, which is this translating to this bottom reinforcement. If we copy this downward and let's see how this reinforcement is bent, you'll see that this is also bent like the bar mark 02. Sorry, this is also bent as the bar mark 01, right? So it means the shape code for this respective reinforcement remains as 21. Okay, now the third reinforcement we have on this model is this our sidebars. So we've identified this, which is bent this way, and we also identified the shape code of this reinforcement at the bottom layer, which is also bent just like this. Now the third reinforcement is our sidebars, and as you have it here, you will see that this is what is straight reinforcement. Okay, so we'll come back here. You will see that our shape code for a straight reinforcement, we have this to be shape code 01, and we also have this as 00, but it is advisable we go with shape code 01, right? So I will create a copy of this and I will take this downward and I will edit this to be bar mark 03, while this is shape code 01, right? Let me move this upward a bit and we can create another copy of this. Okay, so our bar mark 04, let's select this and let's say bar mark 04, and let's look for what our bar mark 04 looks like, right? So if we come to this picture over here, you will see that we have this to be a rectangular bend, right? Rectangular bend. And if we come back to our links, if you see this picture of our links here, you will see that we have this rectangular bend here, but there is an extra reinforcement that is bent into this part and also bent into this part, which is the proper way to bend your links, right? So if we try to identify this on the shape code and we come here, you will see this reinforcement type as, let's see, we'll get to say this as our shape code number 51, right? So we have this to be shape code number 51. Okay, so I will come here and our bar mark 04, this is shape code number 51. So we've successfully identified the different shape code that is required for this reinforcement, and the next step will be working with our material takeoff table. Now we have these various shape code already identified in our material takeoff table, and just in case you intend to get this, possibly you want to use it for your respective project, we have it in the link. You can just check the link in the description and you can get this and use it for your respective project, right? So we also have an extra here why we've identified different reinforcements, including the ones you require for your slab. Let's say you have a slab that requires your chairs, as we choose to call it, right? You can make use of this other table and use it for your respective project. So just follow the link in the description and you'll be able to get this for your respective project. Okay, so permit me to share this screen once more, and I will take my material takeoff table to the right hand side and let me put my respective beam to the left hand side. right? So on this material takeoff table over here, we have the different properties. The first one, we have it to be the member which we are dealing with. The second one is the bar mark, which we've earlier identified. The third one is the type and the size of reinforcement. Then we'll move to the numbers of members in the beam, the bars in each of the beam, the total numbers, the cut length, the shape code, and the different properties as required by your respective shape code, right? So for the first properties we have here, we have this to be our beam 1. So we edit the member name to, we take it from one beam 1 to just beam 1 in order to suit the requirement of this very structure, right? Then the first reinforcement we'll be starting with is the reinforcement having the bar mark 01, right? So we'll edit this from 1 to 01, okay? And the type and size of reinforcement for our bar mark 01, as you can clearly see over here, we have it to be Y16, right? So we'll take this from T16 just to ensure that it matches with what we have on the model, right? So we change this to Y16. Now the next item we need to get here is the number of members on this respective model, okay? Now do not forget that this is our beam 1, and for the beam 1 we have it to be two numbers, right? Which is beam 1 and another beam 1, right? So the number of members we have on this model, will have this to be two numbers, okay? Now the next question is, in each of these beams, how many numbers of reinforcement do we have having bar mark 01, right? So as you can see here, we have four numbers of this beam, right? We have four numbers of this reinforcement in this beam 1. So we'll be taking these bars in each, we're taking this to a total of four numbers, right? Which we can clearly see here as 1, 2, 3, and 4, having shape code 01. Now the next that you require is the total number. Now since we have four numbers in this beam, right, and we have two numbers of this respective beam, so it means we have four numbers in this and we also have four numbers in this. So multiplying these numbers of members by the bars in each will give us the total numbers. So we have this to be a total number of 8. Sorry, that should be 8, right? So we have the total numbers of this bar mark 01 as 8. Now the next item we need to fill up here is our cut length. Let's remind ourselves that the length of our respective reinforcement, be it our diameter 16, diameter 20, is always 12 meters, right? For safety's sake, it is always advisable you will assume 11 or 12 meters. So when you have a 12-meter long reinforcement, what is the length of that reinforcement you are supposed to cut out from the 12 meters in order for you to achieve this bend, right? So what is that length that is required for you to be able to achieve each of these reinforcements, right? So I can have a reinforcement having 12 meters of length, but if I cut 6 meters from that respective reinforcement, I'll be able to achieve my bar mark 01, right? So for us to calculate this, we have to sum up the different parts of this reinforcement that is required as specified by your shape code chart, right? So permit me to, let me cross this because we'll come back to this cut length, okay? Firstly, let me draw a rectangle across both this cut length and the total length, right? So I'll put a rectangle on these two to signify that I'll be coming back to these two cells. So let me come to this part and make this let me make this thick, okay? So this will signify that I am coming back to these two bars because I need to make use of this shape code and this respective A, B, and C's in order to estimate the total cut length, right? So our bar mark 01, what is the shape code? We have the shape code to be shape code number 21, right? So I will come here for my bar mark 01 and I will change this from 41 to shape code number 21, okay? And looking at my shape code number 21, I have what, three sides, which is our side A, our side B, and our side C, right? So it means I need side A, side B, and side C. So I'll quickly take this to, let me take this to dash, and I'll also take this to dash. Okay, so it means I do not require this other two alphabets, right? For this very shape code that we are dealing with. So for our side A, as you can see here, is denoted by this bend here. Our side C is also denoted by this bend, while this side B is the longer part of the beam, is the longer part of the reinforcement. So in order to get the right length of this reinforcement, what we have to do is, let's copy this downward again. We'll copy this from here to this point, and we have to dimension from here down to this part. So we have this to be 344 millimeter, right? So this is the requirement of this specific reinforcement. We have our side A as 344 millimeter, and let's check for the side C. We have for the side C to be 44 millimeter as well. Now the easiest way, you know that this part of A and C is our development length, right? But for this main length here, the easiest way to get this main length, what you need to do is you look at the total length of your beam, right? We look at the total length of your beam, and you have to subtract your concrete cover. So realistically, if we pull this up, so it means we look at the length of our beam, of our concrete beam, and we'll take out the concrete cover, because this reinforcement comes just after the concrete cover, right? So for this respective beam, we are using the concrete cover of 40 millimeter. So it means if I dimension from edge to edge of this beam, let me dimension from edge to edge, because the distance we have here was at the center to center. So I will have this at 7.5 meters. So if I take concrete cover of 40 millimeter from the left and also from the right, it means I am subtracting 80 millimeter from this, and this will give us 7420 millimeter, right? So I will have my side A to be 344, but it's always advisable you make use of a figure that can be easily gotten from your tape measurement, right? So against using 344 for my side A and my side C, I will take a length of 350 millimeter, right? And I'll also take this to be 350 millimeter. While for this part, after subtracting the concrete cover from the left and right, I have this to be 7420, right? I have this to be 7420. So if I add this length to this length to this length, right, I'll be able to get the total cut length. I'll be able to get the total length of this reinforcement, which we need to cut out of our 12 millimeter long reinforcement, right? So I'll just have to pull up my calculator. Let me pull this up, and I'll have to multiply 350 millimeter by 2, and I can add my 7 sorry can add my 7420, right? So I have a total length of 8.12 meters, right? I have a total cut length of 8.12, right? So I'll take here to be 8120. So let me take this downward, right? Let me take this down to this point, and I'll edit this to be 8120. So this becomes 8120, right? So now we have the total cut length. Now the next thing we need to calculate is our total length, because this 8120 is for one number of this reinforcement, right? And do not forget that in each of the beam we have it to be 4 numbers. So in order to get this total length, I have to multiply the total numbers of this reinforcement required in this model by this cut length, right? By this respective cut length. So I will convert this to meters because this value has moved from millimeters to meters. And if I convert this to meter by dividing by 1000, okay, I'll have 8.12, and I can multiply this by 8 numbers, right? So it means the total length of reinforcements required for bar mark 01 on both numbers of beam 1 is 64.96 of 16 millimeter, right? So I will come here and I will take this to 64.96. Let me edit this to 64.96. Okay, so this becomes the total length of y16 required in order to achieve our bar mark 01, right? So we move on from our bar mark 01 to the bar mark 02. And if you found this video helpful at any point, please do not forget to like it, do not forget to subscribe to our channel, and you can also enlist some topics you want us to treat. This topic we are dealing with right now was actually requested by some of our viewers. Okay, so we saw that there are a lot of requests on this topic, so we had to make out time to attend to this, right? So if you have other topics you want us to treat, just leave it at the comment section. And if you find it useful, do not forget to share, do not forget to like, do not forget to subscribe. Okay, so we'll move on from our bar mark 01, or let's say before we calculate the total weight of this reinforcement, let's get the various properties of these four reinforcements, right? These four different bar marks. So for our bar mark 02, let's edit this to 02. We have the diameter to be 20 millimeter. Okay, is a y20 reinforcement, so this changes to y20 20. And the numbers of members, we have it to be two members as well. This has to be 2. Then the bars in each member, here we have it to be 3y20. Okay, so we also have this to be 3 numbers of y20 in each of this beam, and the total numbers of this y20, we have it to be 6 numbers of this y20, right? By multiplying this by this. Now we also come back to the total cut length and the total length. What we need to look at in this case is our shape code, and we've earlier identified for the bar mark 02 also as 21, right? So we'll come here and we'll take this to be 21 shape code. Okay, so for the 21, we also require, for the shape code 21, we also require bar mark, we also require side A, B, and C. And as earlier stated, if you intend to get this for your respective project, you just have to follow the link in the description and you'll be able to get this chart, which helps you to automatically calculate, or it gives you the guidelines and principles to calculate your material takeoff or your bar bending schedule, depending on what you intend to use it for, right? So for our side A, let's copy out this reinforcement as well. Let's take this downward. If we copy this reinforcement to this point and we try to dimension our side A and C, if we take from here to here, we have this to be 400 millimeter, right? This is actually different from the bar mark 01. The first one is 350 approximate, while this is 400 millimeter, right? So it means for and let's check the right hand side as well. From here to here, we have it to be 400 millimeter. So for our side A and C, we'll take this to 400, and this also has to be 400. So taking out the concrete cover from the left and right, which is 800 millimeter, we also have to take this to 74. This has to be 7420, right? And there is an additional 50 millimeter on both sides, so which means the total length here will be, the cut length here will be 8220, right? So we have this at 8220. Okay, so converting this to meters, we will have 8.22 Okay, we have 8.22 multiplied by the total numbers, which is 6 numbers, and this gives us 49.32 as the total length, right? 49.32. So we can take this total length to be 49, right, point 32. Okay, so we've completed for the bar mark 01 and 02, and let's quickly move on to our bar mark 03. Our bar mark 03, which is a straight reinforcement. Okay, by looking at this picture, you will see that this is a straight reinforcement, and this will most likely start just after our concrete cover as well, right? Although it can move, let's say 50 millimeter inward, but let's keep it just after the concrete cover as well, right? So it means will be the total length of this automatically becomes 7420, and this place becomes dash. Okay, this becomes 7420, right? And the total numbers, okay, the bars in each, let's come here. We have the total numbers of 2 because we also have the same two numbers of beams, so this becomes 2. The bars in each, we have it to be 2 times, we have it to be 2 times 3 numbers, right? So this is 3 numbers and 2, right, because it's on both sides. So 2 times 3 will give us a total number of 6. Will give us a total number of 6. So we have this to be, let's change this to 6 numbers of this reinforcement in each of the beam. So the total bars in each, or the total numbers of reinforcement in the complete model, will give us a total of 12, right? And do not forget that our reinforcement, we have the type to be our Y16. Okay, so our cut length, they just have to cut out 7.42 meters from the 16 millimeter. So the total cut length here becomes 7420. Let's take this to 7420, and dividing this by 1000, we have 7.42, and multiplying 7.42 by a total of 12, we have 7.42 multiplied by a total of 12 numbers. So the total length required for our bar mark 03, this becomes 89.04, right? So we'll come here and we'll call this 89.04. Okay, so our shape code in this case, our bar mark in this case, this is bar mark 01, right? So we can leave this as 01. Okay, so for the side required, okay, for 01, the only side we require is this, which is the side A. Okay, so permit me to, let me take this back to 7420, and this is our dash. Okay, so our side A is the 7420. Okay, so the last reinforcement required is our links. Beam 1, the last reinforcement that we have to estimate the properties is our shape code, our bar mark 04. So I'll change it to 04, right, which is our links. And if you take a look at the picture of our links, right, as you can see over here, this is what a proper link should look like. Okay, so we have this part, okay, as one side, we have this part as one side. So it's obvious that this and this we have the same length, this and this we have the same length, then this bend here and here we also have the same length, right? They can also have different lengths, but most likely they are to have the same length, especially this and this with this and this. Okay, so if we come back to our shape code chart, we have this to be shape code 51. Okay, so firstly, let's start off with our details. We have it to be diameter 10 reinforcement. So this type will change to Y10, right? This will be changed to Y10. Okay, do not forget that if you intend to make use of this table for your respective project, you just have to follow the link in the description, and you can get this chart, you can get this table, and an additional chart that will help you to get the shape code of the different reinforcements that are not listed here, right? So the number of members, okay, the number of members, we also have this to be 2 for the beam 1. So this is 2. Then the bars in each member, right? So the bars in each member, what we need to do, as you can see here, it is not given. In some cases they can give you 20 y10 with bar mark 04, but just in case you are not given, right, what you need to do is get the length of this beam, which is from the center to the center, right? Because as you agree with me, your links will not get down to this part. So you get will not get down to this part. So you get the center to center distance and you divide it by the spacing, right? So you get the length, right, and you divide it by this spacing. So the spacing will be able to give you the different numbers of these links that is required in your beam. So we have this to be 7250, and if we pull up our calc and we'll punch 7250 divide by a spacing of 250 millimeter. So it means we require 29 numbers of these links in order to satisfy the requirement of this beam 1, right? So we'll take this to 29. Let's take this to 29. Okay, and the total numbers for the two numbers of the beam 1 will be this multiplied by this, which will give us a total number of 50. Give us a total number of 58. Then the next will be our respective cut length. So if we look at so we'll come back to these two, right? We'll come back to these two as usual. So firstly, we have to look at the shape code. As you can see, we have A and A as equal, we have B and B as equal, then C and D can be different, right? So for our A part, what we need to, in order to calculate this, what we need to do is just like we've done on the bar mark 01, is we have to take off the concrete cover, right? Because this reinforcement will start just after the concrete cover. So if we have a total width of 250 millimeter for this side B, if we have a total width of 250 millimeter, if we take out the concrete cover from this part and this part, we'll be taking off 80 millimeter from 250, right? So if we are to punch 80, sorry, we have to punch 250 and we subtract 80 from it, then we should have 170 millimeter, right? This is also 1.2 meters, and if we subtract 80, we'll have 1.12. Okay, so this part A here becomes 1120. This part B becomes 170. So for this part over here, which is our side C and side D, right? Firstly, let's take this to bar mark 51 to appreciate what we are doing, right? This is bar mark 51. So for the type C and the side C and side D, right, this is mostly, or let's say minimum 50 millimeter, but 75 millimeter is appreciated, right? It all depends on the diameter of your reinforcement. But we're taking this as 75 millimeter. Let's edit this to 75 millimeter, and let's also take this to 75 millimeter, right? So this is not required, we do not have this, so this becomes dash. So to get the cut length of this reinforcement, it means we have to add this, sum all these numbers together. But in this case, do not forget that we have A repeating twice, and we also have our B repeating twice. Okay, so do not make the mistake of just adding this and this other two, right? Ensure you add, you multiply this by 2 and this by 2, so you can get the accurate cut length of your reinforcement, right? So we'll come down to the calculator. let's use the quick calc from AutoCAD. So we will multiply 1120 by 2, and we'll add this to 340, right? And we can also add 150 to this figure. Okay, so in this case we have a total cut length of 2730 for one numbers of this reinforcement. Okay, so let's confirm this number. We have this to be 2730, so we'll change this length. This is the 2730. Okay, so let's take out this last part over here. Let's unselect this line and we can erase this. Okay, so we have the total, the cut length as 2730, shape code 51. These are the different parts of the reinforcement. Okay, so the next thing is to calculate the total length, which is multiplying this by the total numbers, right? So this will be divided by 1000 in order to change this from millimeter to meter, and multiplied by the total numbers. So we'll divide this by 1000, and we'll multiply 58. So this becomes 158.34, right? 158.34. So we'll take this to 158.34. Now there's another line of thoughts, okay, that prefers using, let's say we are making use of this reinforcement. Okay, this is our shape code number 21. So there's another line of thought where you can create a part of the table against using A, B, C, and D, right? So you can choose to edit this to their respective lengths. Okay, so let's say this part is 1000, this part is 350, this part is 350, and this part is 350. So this allows for this 250, the other 350. So this allows for more visuals. Okay, but we are making reference to the shape code as provided by our code of practice. So in that case, we are making use of these annotations, which are the A, B, C, D, and E's, and the rest. Okay, but there's another line of thought that you can also choose to work with this. So in that case, it means against A, B, C, and D, we'll have to create one table here, and we'll have to replace this with these shapes, but I prefer going with this. Okay, so let me take this out and we'll move on to the main topic of the day, which is estimating this cost, which is estimating this total weight of the required reinforcement for the implementation of these beams. So moving on to the topic, or the main purpose of today, is estimating this unit weight and the total weight. Okay, so we'll be dealing with these two cells, and firstly we have to understand what they are all about. So for the unit weight, right, for this unit weight, it is the unit weight of each of these reinforcements per meter, right? As said earlier, our reinforcement is always about 12 meters, and if we cut 1 meter out of it, there is a specific weight we should get for each diameter 16 reinforcements. If we also cut 1 meter of a reinforcement from a diameter 20 reinforcement, there is a specific weight we should get. So these values are in kilogram per meter, and it's measured in kilogram, right? You can convert it to other unit of measurement, but this we are making reference to kilogram per meter. So there's a specific weight each of these reinforcement diameter should have, so long as during the production process proper quality assurance was adhered to, right? They will always have a specific unit weight, and it is universal. Okay, so for our diameter 16 reinforcement, which we have on the shape code 21 and the bar mark 01, the specific unit weight for a diameter 16 reinforcement, which is universal, right, is 1.58 kilogram per every 1 meter. Okay, the weight of the reinforcement is 1.58 kilogram per meter per every 1 meter of the reinforcement. Now, for a diameter 20 reinforcement, the unit weight per every 1 meter is given as 2.47. Okay, so we'll have to edit this cell. We'll have to edit this to 2.47. Okay, now moving back to the next reinforcement, which is our bar mark 03. Our specific unit weight for the 16 diameter reinforcement is still 1.58. And the last reinforcement, which is our links, the specific weight of the unit weight of our reinforcement per meter is 0.62. Okay, it's 0.62 kilogram per meter. So realistically it is actually 0.617, right? But approximately it is 0.62. Okay, so the next thing we need to estimate is the total weight. Now we have the weight per meter and we have the total length, okay, in meters. So it means this weight will appear 64.96 times. Okay, we have, let's take that again. We have the weight for every 1 meter and we require 64.96 meter of this diameter 16 reinforcements for the bar mark 01. So to get the total weight of that diameter 16 reinforcement having bar mark 01 and shape code 21, it means we just have to multiply this total length by the specific weight of this reinforcement, which is 1.58. So that will take us to this part here. Okay, this will take us to 1.58 multiplied by 64.96. So we have this as 64.96. Okay, so the weight is 102.64. So we have 102, we have 102.64. So this is now the total weight of bar mark 01. Okay, this is the total weight of bar mark 01 required. Now the next is diameter 20 reinforcement having a unit weight of 2.47 kilogram per meter, and we have a total length of 49.32. So let's multiply this. So we say 49. Okay, let's take this out. We say 49.32 and 49.32 multiplied by 2.47. Okay, multiplied by 2.47. So in this case we have 121.82. Okay, we have 121.82. So this becomes 121.82. Okay, let's confirm that again. We have 49.32, right? That's right. And we have 2.47. Okay, so you always ensure that your figures are correct, right? Because this directly impacts on your weight. This directly impacts on your estimate. Okay, so the next is diameter 16, 1.58 and a total length of 89.04. So we'll come down here to 89.04 and we multiply 1.58, right? So this is 140.68. Okay, this becomes 140 140.68. Okay, and for the links we'll be having a total length of 158.34 and a unit weight of 0.62, right? So let's multiply 0.62 times 158.34, 158.34, and the next, and this will be 98.2, right? This becomes 98.2. So let's take this to a total weight of 98.2. Okay, so the next part we of having we'll be having our total weight in kilogram and converting to metric tons. But I wouldn't advise, let's take this to a single screen, let's take this to a single viewport. Okay, but I wouldn't advise you add all of this to get the total weight, because what you asked is what how many tons of 16 millimeter reinforcement do I require, or how many tons of 20 millimeter reinforcement do I require for the construction of this beam, right? You will not be asked the total tons. And mind you, the cost of each of these reinforcements are different. Okay, so 1 ton of 16 diameter reinforcement is different. The cost of 1 ton of 20 millimeter reinforcement is actually different. So it's not possible to sum all these values together and give an estimate. Okay, so I've quickly created this to suit what we require on this specific beam. So due to the requirement of this beam, we have need for Y16, we have need for Y20, and we also have need for Y10, right? So I'll be summing up the total weight required for our Y16 in kilogram. This is the values in kilogram, and these are the values in tons, right? So for the diameter 16 reinforcement, and do not forget, if you intend to get this template for your specific project, you can just follow the link in the description and you'll be able to get this file, right? It helps you to estimate. And we also have the other template here where we've separated this different weight. Okay, we've separated this different weight. This is the weight of 10 millimeter, 12, 16, 20 for your respective project, right? And this is where you can sum the different weights according to, if you have 10 millimeter, if you have 12, if you have 16, you can also just calculate their specific requirements, right, based on the diameter. Okay, so let's return back to this, and for the diameter 16 reinforcement, what we need to do is we add this to this. Okay, so it will be 102, 102.62.64 plus 140.68, 140.68, and we have a total of 243.32. Okay, so this becomes 243, this becomes 243.32 kilogram. Okay, because in this case we are no longer dealing with kilogram per meter, because in this case, as you can see here, we have it in kilogram. Since we've already multiplied the unit weight at kilogram per meter by the total length required, so it's no longer in kilogram per meter, but it is now the real weight which is being calculated in kilogram, right? So the next is the 20 diameter reinforcement. So we can just pick out the value, which is 121.82. This becomes 121.82. And the next is our 16, which is 98.2 kilogram, right? So this 98.2, okay, 0.20. So if we go ahead to calculate for these other reinforcements and we sum it under the beam 2, so we can now add the weight of all the 16 millimeter reinforcements both in your beam 1 and your beam 2. So we can come out with the proper total weight of diameter 16 reinforcements required, not just to calculate for the beam 1 in this case, but for the entire equipment foundation beams. All right, so now the next thing is converting this from kilogram to tons. And as you agree with me, in order to convert this from kilogram to tons, what you need to do is divide this by 1000 as well. right? So dividing this by 1000, let me erase this 3. I will have to copy this, okay, so here. And what I'll do is, this is in hundreds, so this will be 0 points, and I will take this out, okay. That's for the diameter 16. This is in 100 as well, so this becomes 0 points, and I take this out, okay. This is in tens, so this becomes 0 0.0, and I take this out, okay. So that's to say, we require about 0.2 tons of this reinforcement, right? This about 0.01, this is about 0.1, and this is about 0.09 tons of diameter 16 reinforcement for us to achieve this simple beam one, right? So to round up the show, the last part will be estimating the cost, right? And this becomes very easy since we have the weight in tons. We have it in tons and in kilograms, right? So all we need to do is get the cost of a diameter 16 reinforcement for 1 ton, right? Let's say 1 ton of diameter 16 reinforcement, for example, is 1k. All right, it could be 1k naira. If I'm using my local currency, it could be 1k dollars. So let's say is 1000, right? So all I need to do to get the cost of this is multiplying this by this, and I will get the cost of the 16 reinforcement required for the beam one, right? Bearing in mind that this has been combined uh, from this and this, okay. So this is the total 16 millimeter. So by multiplying this by tons, if 1 ton of reinforcement is 1k, then I will get the total cost required in order to construct, or in order to get the reinforcement for our beam one, right? Same with our 20 millimeter reinforcement. So if the cost of 20 millimeter reinforcement is 2k, I just have to multiply this by this weight, and multiplying by this weight, it means this is the cost that will be required. So this is how we can come up with our estimation, and this is how we can advise our clients on what it will take to get the reinforcement for this respective beam one. And we can use the principles, we can use the scope, we can use the understanding gathered from this series in order to estimate for your slabs. You can use it to estimate for other structural members, can be your pad foundation, raft foundation, and every other structural member you wish to estimate, right? So if you found this video helpful at any point, do not forget to like it, do not forget to subscribe, and do not forget to turn on our notification bell so you get notified anytime we post new videos on our series. You can use this for your respective project. Just follow the link in the description, and you'll be able to get this plus the BS 866. And now, do not forget that the BS 866 chart is not for sale, right? We are only adding that as an additional material in case you intend to use a reinforcement that is not stated in this typical bar bending schedule, which we have on this other template, and also on this other template over here, right? The chart is not for sale. It's actually provided by your code of practice. So thank you for watching till this time, and see you in the next series.